Well, hey everybody, we are getting ready. We are to look at radicals. We've talked a little bit about radicals before. We know that a radical is honestly, if we want to look at this real quick, I'm going to write it off to the side. Radicals are honestly just a fancy version of an exponent. If we had this random x or root of x, right? Technically, maybe inside if you look, that is it's being raised to the power of 1. And since this is a square root, the index is a 2. It's hidden, but it's there. And we can rewrite this saying the base raised to a fractional exponent, or 1 over 2. These are the same. So you can see the denominator is the index. The numerator is what you raise your base to. So again, we are leaving exponentials and moving on to radicals, but they are fairly similar. They share this ability to convert back and forth. So let's start to get into this and start to think about this. Today, we're really working most of the time with square roots in this. We're going to use factoring to help us simplify these. And what we're really looking for is, even more importantly, is factors that one of the two factors happens to be a perfect square, like the 2 times 2, 3 times 3, 4 times 4, 4, 9, 16, 25, 36, and so on. Okay, let's start looking at how this works. So our first example, example 1. And we're giving us a hint here. We need to factor the radicand with the largest possible square we can find. We have 72 here. So think about our list of, real quick, across it, we can just list them, right? 2 squared is 4. 3 squared is 9. We have 16, 25, 36, 49, 64, 81, we have 100, 121, and 144. These are all of our perfect squares up to, of course, we can, I guess, maybe consider 1. 1 is a debatable one there for me, but whatever. Take a look at this. Here you go. Boom, all the way. You can see all of them from 1 all the way to 12. What are the perfect squares? We need to see which one of these is the largest number that will go into 72 evenly. So if you don't see it right away, just start dividing. And here's a great way to look at it, right? 72. 72 falls somewhere in between here. So it's not going to be this one. If you double this, there's no way that that can go in there. 49 doesn't go into it. Does 36? Let's see. 72 divided by 36 is, oh, wow, look at that. It does. So we could rewrite this as the square root of 2 times 36. More importantly, when you do this, when you break them apart, there is the laws that allow us to rewrite it. We can take this and rewrite it any way we want. We can actually separate these. The square root of 36 times the square root of 2. And like that, then we can say, hey, I can actually take the square root of this. If you put this in your calculator, the square root of 36 is 6. Nothing can be done to that. That's as small as it can get. 6 square roots of 2. And like that, boom, you have just simplified your first radical. And there's a reason why we do this, and you'll see this coming up in our next section. In order to add or subtract radicals, they have to have the same radical. So sometimes they may put these things together, but we don't see it right away until we simplify it. Now, sometimes you'll ask us to simplify radicals, and the radicals have variables in them. Not a big deal. We want to factor these apart so that we can have the most perfect squares possible inside. Let's see what this means, right? Is there anything, let's do the number first because we just dealt with that. Is there anything at all that makes up 5? Let's see. 1 times 5, that's it, because it is a prime number. It only has 1. It's only factorable by 1 in itself. Okay, great. Here we go. So 5 is stays. But now look at this, x raised to the power of 5. We can actually break that up into a bunch of x squares with a remainder, right? So here's 2 x's. We had 5 originally, so I can have another x squared. Now I have 4 x's, and I need one more x to make 5, because when we multiply them, right, base stays the same, add your exponents. There's 4 and 5. But it does something even better for it. We know that we can what? Take the square root of an x squared, and it cancels the square. Take the square root of x squared, it cancels the square. So how many of these are we taking out? 2 of them. Notice what stays behind. We still have inside the square root of 5, and there's one little x left. Almost simplified. What is x times x? Base stays the same. You add your exponents. So 1 plus 1 is 2x squared. And like that, you have simplified this. You can use the same principles we do for this as you can when you have variables. You break them up into groupings of 2 with sometimes a remainder. All right, so that was example 2. Example 3. Oh, look, looks even more complicated. It's not a big deal, okay? It's okay. We have a number outside. Anything that comes outside is going to be multiplied by 2, so we're going to remember that. Let's start to see if we can break this thing apart. And look, I'm making a big square root here, right? Let's see, of our perfect squares, which one of those does 112 go into evenly? So again, you're just using your calculator and dividing by the list of perfect squares. 112, 81. Nope, that's not enough. 112 divided by 64. Nope, that doesn't work. 112 divided by 49. Nope. 112 divided by 36. Nope. 112 divided by 25. That's not going to work. 112 divided by 16. And like that, we just found it. So this is 16 times 7. See, even if you're not great at this, guys, you can just do it piece by piece till you find it. Now we need to take x's and break them up into groups of 2 until we have 13 of them down here. So here's 2 x's, 4 x's, 6 x's, 8 x's, 10 x's, 12 x's, and a single x. So that's 2, 4, 6, 8, 10, 12, 13 x's under here. And now we start doing our simplification, right? All right, we can take the square root of 16. That is a 4. So the multiplication comes outside. Now, how many groups of x's are we going to cancel out here? We're canceling 1, 2, 3, 4, 5, 6. X to the 6th power. And yeah, guys, this is all being multiplied. Let's simplify. What's left? Inside, the only thing left is a 7 and a single x. And then we have what? 2 times 4, that's 8. And the x to the 6th power comes down. And like that, you've just simplified something that looks way nastier than you think, and it actually comes out to something pretty simple. Okay, look at this one. First off, this isn't nice. Absolutely not nice. How are we supposed to simplify this thing? We can put it in a radical. Okay, we got to convert this first off to a radical. So the denominator is the index, the hidden 2. And we got to take this and raise all of this to the power of 8. Because the numerator is in here, right? Spin your calculator. What is 2 raised to the power of 8? We get 256. Because this is the power to power rule. Base stays the same. Multiply your exponents. 1 times 8 is 8. 2 raised to the power of 8. There's the 1 here too. This is x raised to the power of 8. And it's all under a square root. So now we have to figure out again, what is our largest perfect square that goes into 256? And you just can keep dividing until you find one. I found it. 256 is divisible by 64. That's 8 times 8. So here we go. 64 times 4. And we can break these up, right? We have what? 2, 4, 6, 8. And now we can start to simplify. Well, the square root of 64 is an 8. Taking out 1, 2, 3, 4. All the x's come out this time. And we go to simplify. 8 times x raised to the power of 4. The only thing left inside of here, wait, is 4. I must have missed a number somewhere along the line. And this is a perfect example of what happens if you make a mistake and you don't grab the largest perfect factor. What is the square root of 4? We can do this again, right? You can simplify this again. Square root of 4 is 2, so that can come out. And like that, we have 16. Oh, that actually doesn't exist anymore. We totally get rid of the square root. So this actually reduces to 16 times x raised to the power of 4. And that would be it. Good to go, simple, not so bad. Like that, you have an answer. What else do they have for us for examples today? Oh, look, fractions. We hate fractions, right? No, we don't. It's easy. Rewrite this. When you have a huge fraction inside of a square root, you are allowed to take the square root of the numerator divided by the square root of the denominator. What is the square root of 25? 5. What is the square root of 4? 2. There's your answer. That reduces to 5 over 2. You can do the same thing here. Right? Look at this. We could have the square root of 121 x squared x. I'm breaking it up as we go. All right. Now the square root of 25 is 5. And then look at this. This is what, 11? And you have one x come out. 3 times 11 is 33x. Square root of x. And like that, you're done. That's not bad. See, you break it up into tinier pieces and away you go. A lot of algebra is just making it simpler for you as you go along. Okay, and that is it for today, guys. Get out there, do your homework, have a great time. Any questions, make sure you're doing your EOC review.